Welcome to Brain Vision.
Okay, so we know the flow work can be equal to the pressure multiplied by the specific volume. And we know specific volume can be expressed as RTL over P. R is the gas constant for helium. TL is the temperature that's given in this question, which is the temperature of the supply line. And P here is the pressure. So therefore we have P times RTL over P. As you can tell, P can be cancelled out. So I have work is simply equal to RTL. So the gas constant for the helium is 2.0769 kilojoule per kilogram times Kelvin. And the temperature in this question is given as 120 degrees Celsius, which is 393 Kelvin. So now let's plug in back to the equation to determine the flow work of the gas, which is equal to 2.069 kilojoule per kilogram times Kelvin, and then times 393 Kelvin. And this will give us the flow work is about 816 kilojoule per kilograms. And for the next question, we can determine the final temperature of heating in the tank. So first we can set out such equation here, which is UT equal to HL. UT is the internal energy in the tank, and HL here is the enthalpy in the supply line. In this case, the internal energy in the tank should be equal to the enthalpy in the supply line because the flow work in the supply line is converted to sensible internal energy in the tank. Okay. So we know HL can be expressed as Cp times TL. Cp is the specific heat for the helium at constant pressure, and TL here is the temperature in the supply line. And UT can be expressed as Cv times TT. Cv is the specific heat for the helium at a constant volume, and TT is the temperature we're looking for to determine, which is the final temperature of the helium in the tank. So now we can plug in back to the equation. We have CVTT is equal to CPTL. So therefore, TT can be equal to CPTL over CV. So based on the properties of gases in the helium column at the back of the book, you'll find that the Cp should be equal to 5.1926 kilojoule per kilogram times Kelvin, and TL we know is given from the question, which is 393 Kelvin, and Cv is equal to 3.1156 kilojoule per kilogram times Kelvin. So now let's plug in back to the equation to determine the final temperature of helium in the tank, which is equal to 5.1926 kilojoule per kilogram times Kelvin, and then times 393 Kelvin over 3.1156 kilojoule per kilogram times Kelvin, and this will give us the final temperature of the helium in the tank is about 654.99 Kelvin. And these are the answers for this question.